Hi, my name is Marina Boland, and today I'm going to help you calculate the charge and pI on a peptide. So the first step I normally take is to create a number line. Make sure that your number line is big enough where you're going to be able to put information on your number line. And your number line should have the values 1 to 14. This is because these are the values that we use when we look at pH. On the top, you're going to put pKa, and on the bottom of the number line, you're going to place pH. I also like to make a note of what amino acids are either positively charged or have no charge, and negative, or they're negative or no charge. Don't forget your N and C terminals here. A helpful hint is if you know that an amino acid is charged and you can't remember if it's going to be positive 0 or negative or 0, if you see a nitrogen on the end, it normally means it'll have a 0 or positive charge, whereas if you see an oxygen on the end, it normally means it's going to have a 0 or negative charge. The next thing you're going to do is place your amino acids on the number line. Make sure that your line extends down toward the pH because this will be helpful when we calculate the pI. I label each of my lines with the one-letter code for the amino acid as well as the pKa. Next, I put the potential charges each amino acid has on either side of the line. If an amino acid is either negative or no charge, the negative will go on pointing towards the 14, which is the most basic. Whereas if it's positive or 0, you're going to point the positive charge towards the 1 because that's the most acidic. So let's look at 3 different pHs. And these are just for all the charged amino acids. You will not be using all of these amino acids for every single peptide that you do. So at a pH of 3, what we're going to do is we're going to mark where the 3 is, and normally when I do this on an exam, I just use my finger. And we're going to circle all of the charges that are closest to that 3 for each of the amino acids. For the C terminal, that's going to be the negative. Whereas for everything on the right, it's going to be what's on the left of the line. So again, you want to make sure all of the values you pick is closest to the pH. I am going to mark these down on the graph below. If we move to a pH of 7, we see that the values for the amino acids D, E, and H change. They're going to move from the left to the right because now the pH is to the right of these amino acids. We do the same for all the other amino acids. So again, the value that's close to the pH value you're working with, and I put those on the chart below. For a pH of 11, where again, all the values to the left of the pH, you're going to use the value on the right for each of the amino acids. And for everything to the right, you're going to use the value on the left for the amino acid. So now that we could find the charge, let's find the pI. So each of these sections between the pKa's are going to be a different zone. And you're going to find what the charge is in each of those zones until you find out which zone has a charge of 0. I always like to start from the left. So if you look at the left arrow, all the way to the left by pH of 1, you're going to add up all the charges, and you're going to get plus 4 charge. The next zone is between 2 and 3.9. In that zone, the charge is plus 3. The next zone is between 3.9 and 4.1. In that zone, the charge is 2. The next zone is between 4.1 and 6.0. The charge for that zone is plus 1. And then the charge between 6 and 8.4, which is the next zone, is 0. And again, we can stop at 0 because that is what we're looking for. We're looking for the 2 pKa's that are on either side of the 0 charge. So for this case, it's going to be H and C. The equation to find pI is pKa1 plus pKa2 over 2. So for this, it's going to be pI equals 6 plus 8.4 over 2. and we get a pi of 7.2, which makes sense because that looks like it's right between both of those amino acid values. So let's try a practice problem. For peptide WERLH, what is the charge at pH 2, 8, and 12, and what is the pi? So for this, we're using the same exact number line. I just grayed out the amino acids that we're not using for this specific practice problem. So let's start with a pH of 3. Let's find our charges. So again, we're going to use whatever values are closest to the pH. So for the N-terminal, you're going to get a plus, E0, R plus, H plus, C-terminal negative. For amino acids that don't have a pKa, I just draw a line through those areas so that I remember that they don't have a pKa, which means they will never have a charge on them. For pH 7, you're going to do the same exact thing. You're going to write your charges down, add up your charges to see what the overall charge is. And then pH 11, same thing. We're going to look at the charges that are closest to the pH, add them up, and see what the overall charge of the peptide is. So when we're finding pi, we're again going to go through and start from all the way to the left and calculate what exactly the charge is going to be. So all the way on the left, that zone, it's going to be plus 3. Next one's going to be plus 2. Next zone is going to be plus 1. And next zone, which is between 6 and 9, is going to be 0. Notice I totally ignored the lines for the amino acids that are not present. Make sure you are only looking at the charge between the amino acids that are present in that specific peptide. So for this, we're going to get a pi equals pKa1 plus pKa2 over 2 is going to be 6 for histidine, 9 for the N-terminal over 2, and our pi is going to be 7.5. I hope this was helpful, you guys, and good luck on your future exams.